All right, guys. Good morning. I am creating a video. This is a video for practice for inverse functions, finding inverse functions. This is something I created for my students. I haven't used it a bunch because they kind of struggle with when you combine more than one operation. But here's what I'm going to do. I have a bunch of slides. Let me just bring it up this way. And on all these slides, you have two types of cards. One card has a single operation, and you're supposed to find the inverse operation for that card. Or it'll have a series of operations, and you're supposed to go through using PEMDAS and give me the order of the operations, because those are the two things that you really need to be able to do well in order to do inverse functions. So this video is basically going through, and I'm going to randomly kind of choose, I'm going to randomly choose cards, and then I'm going to tell you the inverse, or I'm going to go through using PEMDAS and tell you the order of operations. Those two things basically are what you need in order to solve inverse functions. All right, so I'm going to put it in a book format, and what I'm going to do is I'm going to spin it, and wherever it lands, I'm going to tell you what the inverse is, or I'm going to do PEMDAS. So now you're watching. Hopefully, when I stop at a place, you will also be saying, oh, that's the inverse is this, blah, blah, blah. So you should be playing along. So let's get going. I'm going to start. Okay, here's my first one. Okay, the inverse of something to the 3/4 power would be taking it to the 4/3 power. When you multiply these, you should get, every time you do the inverse of something that has x in it, you should get x. All right, whatever the variable is, that's what you should get. You should get 1x to the 1 power. That is what you should get every time you do the inverse. And if you don't, that means you've made a mistake. Okay, so now let's go back. Let's go to another one. All right, here. So 10 to the x power, what's the inverse of that? Oh, that would be the log base 10 of that. And if you took the log base 10 of 10 to the x, you would get x to the first power, which is what you should get. All right, let's try another one. All right, what's the opposite of 7 to the x power? That's an exponential. So the opposite would be log base 7. That will give you x. Okay, so that's the inverse. All right, here. Now this one, we have to go through, and we're going to use PEMDAS. So what's the first thing you should do here? Well, the first thing you should do is whatever's inside that fourth root, you're going to do that first. So the very first thing we're doing is we're multiplying x by 3. And then we subtract 2. And then we're taking the fourth root. And then we add 6. Okay, now, if we were doing the inverse, we would do subtract 6. We would do raise it to the 4th power. So this would be x minus 6. We would raise that to the 4th power. Then we would add 2, and then we would divide by 3. And we're going to do it in this order. We're going to do this first, this second, this third, this fourth. So if I start with y equals x, first thing I'm going to do is subtract 6. Then I'm going to raise that to the 4th power. And then I'm going to add 2 to that 4th power. And then I'm going to divide the entire thing by 3. That would be my answer. And if I did f of y, I should get x. That's how I can check it. So if I use my graphing calculator and I take this inverse and I plug it in here, I should get x when I'm done. If I don't get x, then that means that these two are not inverses. Hope that makes sense. All right, so let's keep moving. Let's see. What's the opposite of adding 4? Well, this one's easy. You would subtract 4. And when you subtract 4, guess what you're left with? You're left with x, 1x. which is what you should be left with. Okay. All right, this one, what's the opposite of multiplying by 6? Dividing by 6. And what are you left with? You're left with x, as you should be. Whenever you take the inverse, you should be left with x. All right, so, okay, we have another one. So we are going to go through and we're going to use PEMDAS. All right, we start with parentheses. So inside the parentheses, we're taking x and we're raising it to the 5th power. And then we subtract 2. And then we multiply by 3. And then we add 7. Those are the steps according to PEMDAS. That's what we're supposed to do first. Now, if we were trying to find the inverse, we would do subtract 7. We would divide by 3. We would add 2. And then we would take the 5th root. So if we had this, y equals x, subtract 7, divide by 3, add 2, take the 5th root of the entire thing, and we're done. And again, if we did f of y, we would get x. That's what we should get. If we take the y and we substitute it in here, the inverse, put it in as an input. If this is correct, we should get x. That's how you check it. If you have a graphing calculator, you should do that. In fact, I might do it. Okay, what's the opposite of subtracting 7? Obviously, it is adding 7. Let me change the color. Add 7, we get x. All right, next, let's see. Okay, what's the opposite? What's the inverse of the cube root of x? Well, we would multiply this whole thing, raise it to the 3rd power, and that would give us x. All right, boom. Okay, now let's see. Here's another one. We're doing PEMDAS. What goes first? Well, we got parentheses, so we're going to start with the parentheses. This part here, we are squaring x. That's the first thing that we did. Then we subtract 4. Next thing we do. Then we take the log base 3, so it's log base 3 of all of that stuff. And then we multiply by 5. And if we wanted to do the inverses, it would be divide by 5. We're going to take 3, whatever that stuff is. We're going to have a base of 3. Then we're going to add 4. And then we're going to take the square root. So we're going to do this first, second, third, fourth. Start with y equals x. Change the color just so you can see. We're going to divide x by 5. Then we're going to raise all of this stuff to the 3rd power. Then we're going to add 4. And then let me clean it up a little bit so we can see. Then we're going to take the square root of this entire stuff. And that would be our inverse. Again, if we do f of y, we should get x. That's our check. If we get x to the 1 power, then that means this is in fact the inverse. That's how you check it. All right, let's do a couple more. All right, here's another one. What happens first? Is there parentheses? Yes. So we are going to do what's inside the parentheses. Actually, what we do have, it should be, we have like 2 parentheses because that stack fraction is basically an implied parenthesis. I'll take that away. But so the very first thing we're doing is we are squaring the x, then we add 4 to it, then we divide by 6, and then we raise that whole ratio to the 7, the base of 7. So if we're doing inverses for all of these operations, we're going to take log with the base of 7 of x. And then next thing we're going to be multiplying by 6. Then we're going to subtract 4. And then we're going to take the square root of whatever we have. So we're going to do this first, this second, this third, this fourth. Come down here, we have y equals, we have x, take the log of that, log base 7, and then we're going to multiply that by 6, and then we're going to subtract 4, and then we're going to take the square root of all of that stuff. And again, to check it, if we do f of y, if we take this and plug it in here, we should get x to the first power. That's how you know it's correct. All right. I think I'm going to do, what do we got here? We've already done that one. All right. What's the opposite, or what's the inverse of log base 23 of x? Well, you would basically raise this to the 23rd. You would have a base of 23rd. So basically 23rd with the base of 23, log base 23 of x would give you x. So that's how we know that is correct. So we're raising it to, we have a base of 23 and we raise that part. I think I'm done. Let me see here. Let me go through, and I'm going to show you one quick thing here. All right, now I'm going to show you how to check this. So what we're going to do is we are going to go get our calculator, and I'm going to make this handheld only so we can put these both on the same screen. Let me see, can I do that? How come I can't move it? It's not moving. Why can't I move this? Let's see, can I get rid of this stuff? So how do we get this? All right, so we're gonna take this, move it here, and then we're gonna get the iPad. We're gonna bring that over here. Now, so I am going to check this by, first thing, I am taking, where is it? We are going to enter the original function, so it's 7 to the, we are going to have a stack fraction. So up top is going to be x squared plus 4. In the denominator is going to be 6. And then we're going to press enter. Now this should be an exponential function. Let's do menu 45 to see what it looks like. This doesn't look like an exponential function. It looks like a quadratic function. 7 to the, yeah, it's 7 to the x squared. It doesn't look like an exponential. I expected an exponential, but it's not an exponential. That surprises me. All right, but I'm gonna keep going. Let me zoom out one. We'll make this the center. Yeah, it's not an exponential. I thought it would be an exponential. A little surprised by that, but all right, so now what I'm going to do is in the second function, I'm going to put the inverse, which is going to be the square root of 6 times the log with the base 7. Actually, let's do it this way so everyone can see exactly what I'm doing. All right, so, and then this is going to be x. And then it's going to be minus 4. Press enter. And this is what we have here. Now, to test whether or not these two are actually inverses of each other, I'm just going to enter another, I'm going to graph another function, which is a composite, where I'm going to take the original function, f of 1, and then for the input, I'm going to take the inverse, and then I'm going to put the x there, press enter. And as you can see, even though it doesn't go all the way through the origin, you can see that this part here is definitely y equals x. So, so that means that these two are in fact inverses, because when you get done, you wind up with y equals x, or a version of y equals x. It's not the complete y equals x. It's, I'm not even, well, it would be y equals x, but it starts at, what does it start at? It starts at 2 when x is greater than or equal to 2, because otherwise the functions don't actually have an inverse if we don't constrain the domain. All right, but anyway, I hope this has been helpful. To me, the most important thing when you're trying to do inverse functions is you've got to know what the inverse of each operation is. You should be able to do that in your sleep. The second thing is you should also be able to, once you're given a function with a bunch of different operations, you should be able to pull them apart using PEMDAS, and then you're going to do the inverse operations, and pretty much you're done. All right, I'm going to stop this. Let's see, where is my, but have a good day.